Hello dear student. In the last video we solved first and second question of exercise 6.1, isn't it? Now in this question we are going to solve the third and fourth question of exercise 6.1. Now the third question is in the figure 6.15 angle PQR is equal to angle PRQ. So we have to prove that angle PQS is equal to angle PRT. So let us try to understand this question. So this PQR angle and this PRQ angle are equal to each other. They are having the same measurement. So we should show that the exterior angle formed, that is PQS, and the exterior angle PRT are also equal to each other. That thing we have to prove in this question. Let us see how to solve this question. Okay. So before solving this question, so let us recall what we did in the first question and second question, right? So whenever we got a straight line, we consider then straight angle. Straight angle means which is always equal to 180 degree. Whatever may be the number of points, it is get divided into, it is always an 180 degree sum, right? So here in this question also we are considering the straight line ST. ST is our straight line. On this ST straight line we are taking a ray QP. Okay, so we are taking this QP ray. Okay, by this QP it is standing on this line ST, and at this Q point we are getting two angles, isn't it? So whatever ray we get on a straight line, it divides our straight angle into parts, right? So here also the ray QP is dividing our straight line into two parts. Whenever we add these two parts, our sum should always be equal to 180 degree. So that is a linear pair of angles, isn't it? So the same thing we are considering here also. Angle PQS plus angle PQR is equal to 180 degree. The reason is linear pair of angles. Okay, next PQR we are keeping in one side and shifting this PQS to other side, and this relationship we will consider as the first relationship of the solution. Okay. So in the second part of the solution what we are going to do is, again on this ST straight line we are going to consider our ray PR. Okay. So by this ray PR, again we are getting two angles here, that is angle, here ST we have, that is angle PRQ and angle PRT, like this two angles we are getting, right? So that sum of the two angle is also equal to 180 degree, because it is also a angle formed on the straight line. So here also PRQ we are keeping in one side and shifting PRT to other side of the equation. It has become minus PRT. So consider this one as the second relationship. So why we did so is, in our given question it is given that PQR and this PRQ are equal to each other, isn't it? These two terms are equal to each other. So whenever we find out the values for these two, it is possible for us to do the simplification very easily. Okay. For example, let's imagine that, wait for a minute, just imagine that you have x is equal to 3y, okay, x is equal to 2y, or x is equal to 2z, like this you have. Okay. So when we equate these two, the same term xx get cancelled, just you will get the other two sides. 3y is equal to 2z, like that you are going to get. Okay, so that is the concept here. So it is given the question that PQR is equal to PRQ. When we equate these two relationships, this equal terms get cancelled. Means RHS get cancelled and we are going to get only the LHS get cancelled. We get only the RHS of our relationship. The same thing here we did. PQR and PRQ are equal. So equal terms we remove from our relationship. So 180 degree minus PQS is equal to 180 degree minus angle PRT. So this 180 degree, same term both the side get cancelled. So minus also get cancelled after cancelling 180 degree. So lastly we get angle PQS is equal to angle PRT, which is asked in the question. Okay, let's move on to the next question, question number 4. And the solution of question number 4 is very easy. Within 1 to 2 minutes we can do, and it is very easy to understand the solution also. So in the given figure 6.16, if x plus y is equal to w plus z, then prove that AOB is a line. So there is a figure. In that figure you are getting a AB line. AOB is a line, that thing you have to prove. With the help of this relationship, x plus y is equal to w plus z. Okay, now look at the solution. Okay, we can say that in the whole figure, so we are getting 4 angles at our O point, right? Like this we are getting 4 angles, isn't it? So that 4 angles are angle X, angle Y, angle Z, angle W, right? So in circle shape we are getting all the 4 angles. Like this a circle shape is there and that is divided into 4 angles. So this point, at this point always we are going to get a complete angle 360 degree. So whenever we add all these 4 angles, we are going to get the sum 360 degree, right? So that is our complete angle. That's why we are getting 360 degree. Now it is given in the question that x plus y is equal to z plus w, which means in the place of x plus y also, z plus w also, you can substitute x plus y, or in the place of x plus y you can replace it with z plus w. Like that also we can do. But here we are proving this AB as a straight line. So we consider the angles formed on this AB only for our proof. The angle formed on this AB line are XY also, ZW also. So here vice versa, in both the ways you can do. But I substituted x plus y in the place of z plus w. Okay, so that is 2x plus 2y is equal to 360 degree we got. 2 is a common number. 2 into x plus y is equal to 360 degree. X plus y is equal to 180 degree. Dividing this 360 degree from this 2, shifting this 2 here to the denominator, we are going to get 180 degree as a sum. So as we know, when we are adding any two angles, if we are getting 100 degree as the sum, which is a linear pair, then that line where you are getting the two angles, that line will be considered as an straight line. So here on x and y we are getting on this AB line. So AOB will be considered as an straight line because the sum of x plus y is equal to 180 degree. So this is the solution of question number 3 and 4. Thank you.